Yesterday, quick revision on factorising, expanding and those kinds of things. So today we're going to do some more familiar work, I hope, which is with algebraic fractions. So a few things to remember. First of all, where possible, you want to cancel any fractions first. Okay, you don't want to make things bigger than they need to be. If you are adding or subtracting, you must find the lowest common denominator before you add or subtract. When you are multiplying, you cancel first and you cancel anything on the top with anything on the bottom. And then once everything is cancelled, you multiply the numerators and then you multiply the denominators. If you are dividing, multiply by the reciprocal of the fraction that follows the division sign. What was my little thing that I said last topic to remember how to do division? What? I told you guys, didn't I? What is it? Leave, kiss, flip. Did I say that guy to you guys? Oh, all right. You did, but you didn't remember it. Okay, so you leave the first fraction. Kiss means you turn the divide into a times, and flip the last fraction upside down is what you do for a division. So into the examples. So question 1 says to cancel, to simplify those fractions there. So in A, first of all, we look at the numbers, 12 and 2. We can divide by 2 to get a 6, and that means that 2 would cancel completely away, or it would leave a 1 there if you'd like to put the 1. With the letters, I have 1m on the bottom, which means I can cancel off the squared and still have 1 left on the top. That's everything cancelled, so I write down what is left. I have a 6mn on the top, and the only thing left on the bottom is a 1. So you can put over 1, which is still technically correct, but when the denominator is a 1, we prefer not to write it because that is more simplified. Part B. Okay, again, we want to cancel things, but when there are 2 terms on either the top or the bottom of your fraction, to cancel them off, you have to be able to factorise out the common factor first. Otherwise, the temptation, the common mistake that I see every year is people doing stuff like, oh, a 9 and a 9, cancel it off. No, never, 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 all right? So, you factorise the top. I can take a 3 out of both of those terms on the top, and that would leave me with an A minus 3 left in the brackets. Still have the 9 on the bottom. Now that I have factorised, I can cancel the number out the front with the bottom. So I can cancel divide by 3, and I would get a 1, divide by 3, and I get a 3. So writing down what's left, because my 3 out the front cancelled off, I have A minus 3 on the top and the 3 on the bottom. So testing you, can I cancel off the 3 with the 3? Yeah. No. That's the same as doing the 9 with the 9 over here. Unless it can come out of both terms, you cannot cancel it off because there's 2 terms on the top. You can't just cancel one of them. Okay, when they're added and subtracted on the top of a fraction. So my rule is always factorise first and cancel from the part that you factorised out. Yeah, Charlie.
So does factorising just put the 3 on its own?
Yes, I took a factor of 3 out of both of them, and because that's multiplied with that, when things are multiplied, you can cancel off factors. But when they were just adding or subtracting, you can't just do it from 1. Okay, next question 2 says to simplify, and when you look at those, we are adding and subtracting 2 fractions. So the process is that you always want to get a common denominator first. To do that, the easiest thing to do is to multiply the 2 denominators together. So I'm going to do that. 2a times 5 makes 10a. Now, to find out what happens on the top, now if you want to write the little instructions down, I'm timesing those 2 things together. That's how I got the 10a. To work out what goes on the top of your fraction, you multiply diagonally. So I do 3 times 5. I always do the left side on the top diagonally from the top. Does that make sense? That side first. So 15 Then it was a minus sign in my question, and I multiplied diagonally the other way. 1 times 2a is 2a. Can I simplify anything in there? So because there's two terms on the top, they're not like terms, so I can't add or I can't subtract them. One has an a and one doesn't. I would be checking to see if I could factorize anything out. 15 and 2a, there's no common factor there, so no, I can't simplify that any further. Don't even think of cancelling that 15 and that 10 in any way, shape or form. Right? Okay. Unless you can factorize out of both of them, you can't cancel it off. That's it. Let's do it again for B.
Can't you do 2?
I can't take a 2 out of 15.
No, 2 out of 10.
But I have to take it out of both, is what I'm saying. It's because that's why if there's two terms on the top, when they're added or subtracted, you have to be able to take it out of both of them. Yes. And so because I can't take 2 out of this one, because I can't factorize anything out of those, I can't simplify any further. Shh. Guys, that's a very important thing, because I tell you, every year, people try to cancel stuff off in these kind of questions. So make sure, you're going to remember, you guys aren't going to make this mistake. You're going to be the first year that never makes that mistake. All right. Part B. Same process again. We want a common denominator. So we're going to times the 3 with the 2, which gives a 6. No, we just times the 2 bottom. Don't worry about the minus sign yet. Just 3 times 2 is 6. Timesing diagonally. 2a times 2 is 4a. That's where the minus sign goes there after the 4a. Then times diagonally the other way. 3 times a is 3a. Now the top, there's two terms there, but they're like terms this time. 4a minus 3a can collect up to be 1a, or just a over 6. That's it, nothing left to cancel, done. C and D, they're getting a little bit more complicated as we go through this question. This one's more complicated because I already have two terms on the top before I even get a common denominator. But follow the process. The process is multiply the two bottom numbers together. So 4 times 5 is 20. Whoa, did you break it? Okay. Then multiply diagonally. Now I'm multiplying the m minus 3 with the 5. Now I have to multiply both of the m and the minus 3, which means when there's two terms, you want to put them in brackets. So 5 bracket m minus 3. Then I have my plus sign. Girls, can we stop the chatting, please? Then we have the plus sign, and I multiply the other way. The 4 is going to multiply by m plus 7. Okay? I strongly suggest you always do those brackets first. Don't try and expand out straight away, because, again, that's a common mistake, especially when there's minus signs in here, like will be in the next one. So, expand the top out. 5 times m is going to be 5m minus 5 times 3 is 15. That's the first bracket. Second bracket, we have a plus sign. 4 times m is 4m, and 4 times 7 is 28. That is all over 20. I have like terms. On the top, the 5m and the 4m collect up to make 9m. Minus 15 plus 28 makes a positive 13, all over 20. Again, because I still have two terms there on the top, you check to see, can I factorize anything out of the 9 and the 13? 13 is a prime number, so unless I can take 13 out, it's not going to happen. So I can't simplify any further. Part D. Part D. The denominators are the messy thing this time. But the process still works. Times them together. It will make, you need to put them in brackets. So it'll be 2w minus 1 and w plus 3. Now, to do my timesing diagonally, 3 is multiplying with the w plus 3. So 3 bracket w plus 3. Minus sign, from the question and do it the other way. Seven times by 2w minus 1. So 7 bracket 2w minus 1. So this one is the minus sign in the middle. Be careful when you expand that out. The first bracket, I will get 3 times w, 3w, plus 3 times 3 is 9. Minus 7 times 2w will make negative 14w. And minus 7 times minus 1 will make a positive 7. The bottom you don't need to expand out. Leave it factorized. We only expand the top because there's often things in there that will collect up and become tidier. So on the top, the 3w minus 14w makes minus 11w. 9 plus 7 makes a positive 16. Over the same denominator again, don't expand it out. Okay? So that is adding and subtracting. And I think for a lot of people, adding and subtracting is actually the harder one of these types of fractions because you have to get that common denominator. Multiplying and dividing on the next page, remember that some of these symbols have been changed, so please fix them in your booklet as we go through. These ones are meant to be our multiplication ones. So this is a multiplication sign, and that one's a multiplication sign. The ones in question 4 are division signs. Multiplication and division, you don't have to have the common denominator. However, just make sure, again, if there is 2 terms on the top or the bottom of a fraction, that you factorize them first before you cancel things off. So the first one, I don't have that problem. I'm just looking top and bottom. I can cancel an m with an m. The 9 and the 3, I can divide by 3 to get a 1 and a 3. Once I have cancelled everything that I can see to cancel, I multiply what is left. Just multiply the tops together. So 4 times 3 is 12 on the top. I also have a p on the top. On the bottom, I have a 1 times a 7, which is 7. And I do have an n still on the bottom as well. And that's it. Question B, I have 2 terms. See the 2 terms sneaking into my fractions there? So let's see if we can factorize first. On the top of the first fraction, I can bring out a common factor of 5, which would give me 1 take away 3m.
Oh, I see. No.
Over 2. Now that is going to be multiplied by 3 over, can I factorize the bottom of that other one? Nope. And even though I have factorized, I'm wanting to cancel now, but this is 1 minus 3m and that's 1 minus 5m. They're not actually the same, so I cannot cancel them. There's actually nothing I can do to cancel anything in that question. All I can do is multiply the tops and the bottoms together. So the 5 and the 3, I would multiply them on the top. 5 times 3 is 15. And I would have 1 minus 3m. On the bottom, I'm going to multiply the 2 with the 1 minus 5m, and they just sit next to each other like that. I can't actually cancel anything, unfortunately. Question 4. Simplify. These are the divides. So divide is leave, kiss, flip. Means leave the first fraction exactly the same. Kiss, the divide turns into a times, which looks like a kiss. And flip the second fraction upside down. So it is now 5z. Oh, make sure your z looks like a z and not a 2 like mine kind of did. Let me see if I can make that a bit pointier. Over 3x. Now it's a times problem, which is exactly the same as question 3. We want to look to cancel. So x and x cancels. 5 and 5 cancels. Once I've cancelled everything, times what's left. On the top, I have a 5, not a 5, the 5 cancelled. I have an 8, a y, and a z. On the bottom, the only thing left is the 3. Last question, B, another division. So always start by rewriting the question. Please don't try to write over the top of the question in the test. Rewrite it. Don't be lazy. All right, so we're going to have 2a minus 6 over 5a minus 20. Leave. Kiss means turn into a times and turn the second fraction upside down. A minus 4 over a minus 3. Then factorize. So I'm going to do my factorizing on the next step. Some of you might have factorized straight away. That's okay. So factorizing. The first fraction I can bring out a 2, which gives me a minus 3 inside the brackets. Hopefully you're confident with your factorizing after practicing last lesson. On the bottom, I can bring out a 5, which would give me a take away 4. The second fraction, I can't factorize anything, but notice, I'm going to put them in brackets because they are the same as the ones in the first fraction. So I can cancel a minus 3 with all of a minus 3. As long as I'm cancelling all of it off, it's okay. Just don't try to do one term at a time, okay? And a minus 4 and a minus 4 cancels completely. All that is left is a 2 on the top and a 5 on the bottom. That's it. Practice, practice until you are confident that you've got it, which will be the whole exercise.